All right, in this video, we're going to use the power rule for derivatives to take the derivative of these three functions. So before we get into the actual derivatives, let's just review the power rule. And the power rule says that the derivative of x to the power of n is equal to, well, we could actually combine this with the constant multiple rule, so we could put a constant out front, and the derivative of something that looks like this, c times x to the n. For example, 3 times x to the third is equal to n times c times x to the power n minus 1. So what's going on with the power rule is the power pops out front and decreases by 1. Okay, so let's look at these three problems. Let's look at the derivative. Not DDF. That's the derivative of f of x is equal to the derivative of x cubed plus the derivative of negative 4x plus the derivative of 5. And also we know that the derivative of a constant, is equal to 0. Okay, so first term, derivative of x to the third. Well, the 3 pops out front, drops by 1. So f prime of x should be equal to 3 times x to the second power. And we'll take the derivative of negative 4x. So that's a minus 4 times x to the 0 power. So right now we have x to the first, if x to the power of 1. If that power drops by 1 to 0, x to the 0 is equal to 1. So actually, you know what? Let's just put x to the 0. And the derivative of 5 is 0. Okay, so when we simplify that, that's 3x to the second power minus 4. All right. Now, if we look at g of x, so if we have g of x, it's negative x to the fourth over 2. Well, that's the same as saying negative 1/2 x to the fourth power. So let's say g of x equals negative 1/2 x to the fourth power plus 3x to the third power minus 2x to the first power. So when we apply the power rule, we'll have g prime of x is equal to, well, the 4 comes out front, so we have 4 times negative 1/2 times x to the third power plus, now with that second term, the 3 comes out front, so that's 3 times the 3 that's already there. Ooh. I don't know why that made a circle. Times the 3 that's already there, times x to the second power, power drops by 1, minus 2 times x to the 0 power. So this is x to the first, and this drops by 1 to x to the 0. So let's simplify this. The 4 times negative 1/2, that's a negative 2. X to the third power, 3 times 3 is 9. So that's plus 9x to the second power. And x to the 0 power is equal to 1. So we have a minus 2. All right, and that is our derivative of the g function. Now for the third problem, we could rewrite this. We could split this up into three fractions. So we have like the 3x squared over x, we have the x over x, and we have the 1 over x. All right, so we could rewrite this as 3x squared over x minus x over x plus 1 over x. And so if we simplify this and write it in the form of a form that aligns with the power rule, so x to a power, in this first term, 1x will cancel, so that's a 3x, minus x over x, which is 1, plus 1 over x, which is x to the negative first power. So now, when we take the derivative, so y prime, if we apply the power rule and the constant rule for the minus 1, that would be 3x to the 0 power plus the derivative of a constant is 0 plus, now the negative 1 pops out front and decreases by 1, so that's a minus 2 power. So we have y prime, once we simplify, 3 times x to the 0 is 3 times 1, which is 3, plus 0, minus x to the negative 2. And we could rewrite, for our final answer, we don't want to leave negative exponents, so we could write the x to the negative 2 as 1 over x squared. So that's 3 minus 1 over x squared. Okay, so it looks good. So let's separate. There's problem number 1, problem number 2, problem number 3. Okay, so that does it for our application of the power rule for, in this case, polynomials.